Graph the function shown. Identify the period, domain, and range. So here we have f of x equals negative 2 cosecant 1/2 x plus 2. A lot going on here. We have a vertical reflection with a negative sign, vertical stretch by 2. We have a vertical translation of 2 up, and we also have a horizontal stretch by a factor of 2. So what I'm going to do is I'm going to graph g of x equals negative 2 sine of 1/2 x plus 2, and then I'm going to go ahead and convert it into a cosecant function. So we'll start off by finding the period of the function. Period is 2 pi over b, which is 2 pi over 1/2, which is 2 pi times 2 over 1, 4 pi. Okay, so one period of the function is 4 pi. So what I'm going to do is change the scale on the graph. I'll make this pi, 2 pi, 3 pi, and 4 pi. This will be negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Okay, so next I'm going to draw the midline. Since there's a translation of 2 up, the midline is going to be at plus 2 with a y. So there's your midline. Now, sine function starts at 0 for the midline. It's hard to keep track of, but it's 0 relative to the midline, not 0 relative to the entire graph. Okay, now the period is at 4 pi, so that means all the way at 4 pi it's going to start to repeat, and 2 pi is going to be halfway in between, like that. And now it's a negative 2, so that means a vertical reflection and stretch by 2. So instead of being up 1 here, I'm going to be down 2. Instead of being down 1 here, I'm going to be up 2. That's my reflection. And the pattern continues over here. So I'll go ahead and sketch this real quick. Okay, now the zeros relative to the midline become asymptotes. So I'm going to have an asymptote here, there, there, and there. And the local maxes and mins, those become the turning points. Like that. Okay, and a quick comment on drawing the curves. This one I just drew is probably a better representation. This first one's more like a V. You want to try to make them more U-shaped if you can. Okay, so there's our finished graph. Now let's talk about period, domain, and range. Period we already said was 4 pi. The domain. X is an element of the set of real numbers such that, let's find our asymptotes. They're every 2 pi starting at 0. So we can just say x is not equal to 2n pi. And again, remember that n is integers, so 0 times 2 pi is 0, 1 times 2 pi is 2 pi, 2 times 2 pi is 4 pi. So you're just getting those multiples of 2 pi starting from 0. So for the range, we're going to use interval notation. Negative infinity, comma, and it goes all the way up to 0 is the max there. And we put the square bracket because it is including 0. Union with 4, comma, infinity. So this says the range is all negative values up to 0 and including 0, and then from 4 all the way up forever. And there's a gap between 0 and 4, not including 0 and 4, where there are no outputs. Okay, so there's the graph and the domain and range.